Okay, now I'd like to analyze the derivatives to identify characteristics of the function. With the first derivative, we can see it will be undefined when x equals 0, and it will equal 0 when x equals 4. So those are going to be the two important points for us to take a look at. And for the second derivative, we have a very similar kind of formula here. It's going to be undefined when x equals 0, and it will equal 0 when x equals 6. So I'm going to create a sign chart for each of these. For the first derivative, so let me label that g prime of x. The important points we found were 0 and 4. I'm going to mark here that the derivative is undefined. It's not defined at 0, but it equals 0 at 4. And then I can choose some test points, and I want to think about the factors of that derivative. Recall the factors, it's negative 10, x minus 4, and x cubed. And so when x equals negative 1, negative 10 of course is negative, negative 1 minus 4 is negative, and x cubed is also negative. So it's negative overall. For a value like 2, negative 10, of course, is still negative. 2 minus 4 is still negative, but the cube is positive, so it's positive overall. And then finally, for a value above 4, anything above 4, we get a negative value, and then a positive. 10 minus 4 is positive, and a positive in the denominator, so negative overall. So the function will be decreasing, then increasing, and then decreasing. And what this means, going from increasing to decreasing, means that 4 is going to be a local maximum. The value at 4 is going to be a local maximum. But we don't get a local minimum at 0 because the original function is undefined. That's outside of the domain. We can do a similar analysis of the second derivative, but this time with the values 0 and 6. Again, it's not defined at 0, and the second derivative equals 0 at 6. At negative 1, the factors we have are 20, which is positive. Negative 1 minus 6 is negative, and the fourth power is positive. Negative 1 to the fourth power. Something in between 0 and 6, like 2, we have positive 20. 2 minus 6 is still negative, and to the fourth power is still positive, so negative again. And finally, at 10, we have a positive. Of course, 20 is constant, but now 10 minus 6, because it's bigger than 6, is positive, and positive in the denominator, so positive overall. So this is going to be concave down, and concave up, right? The original function will have those characteristics. And we can see, because concavity changes at 6, I can see that there's going to be an inflection point at x equals 6. Okay, so with those characteristics, we're able to make a graph, and let's do that in the next video.